Okay, that was a lot of information. Deep breath. I'm not going to make it any better, right? Okay, so I'm also not going to follow the clock. I've talked to the organizers about that. I got a guest speaker added to my slides. Yes, there'll be applause. And I have conferred with Shinya, and he will keep things short in the closing remarks. So settle in, loosen up. It'll be fun. For everyone who's in the room, I have pony stickers to make up for it. For everyone who's not in the room, find me. I'm all over the place. You can have stickers. Okay. If you don't know who I am, I understand the headshot is about 10 years old, and so you might not recognize me. I am Josh Moore from the OME Microscopy environment. For about 18 years, I worked with Jason at the University of Dundee, designed OME, designed the image data resource, and then I've now moved on, but I'm still very much in OME. And so what I want to talk about is what's the future? What's the next thing? And what does it mean for all these great projects that you all are talking about? It's wonderful to see what's happening with OME. We worked so hard on it, right? And to see what's going on, but to know that you're going to need more things, and we need to bring the community ever more together. I would love to be able to sit with everyone and have lots of little focus groups, but we'll find the time we can. So in my new role, starting, I guess, at the beginning of last year, I am the head of research data management at German BioImaging, which is a scientific nonprofit representing all the core imaging facilities in Germany. I'm funded by NFDI4BIOIMAGE, and there I'm a task lead. And I'm representing Steffi, the spokesperson of the consortium, as well as the chair of German BioImaging. She couldn't be here. Her apologies. There are so many RDM meetings going on at the moment. Everyone wants a piece of this pie. I guess it makes sense. Usually I would start off by telling you about Derby so you understand more, but there's a poster, and I was planning to run over even before we added Juan. So just come and talk to me. Thanks to the team at SSBD. Where are you? For printing the poster, there was a snafu in getting it here. And if you really want to get involved, you're welcome to come to the Trends of Microscopy meeting the week of the 17th of March in Germany. It's a great retreat. We build an on-site research data management system to host all the data that's produced on-site. So kind of a way to get your hands dirty. That's been quite fun. All right, so what the heck is this NFDI thing? It's Germany's National Research Data Initiative, started about 2020, and in 3 consecutive years, they funded 28 consortia across the spectrum of research data to say, can we link all of our data outputs, right? Really everything. Can we build up really the human capacity? This isn't about hardware. It's a little bit about software, but it's really about having the people to make this work. The consortia are across the spectrum. There are 8 in life sciences. The others that were dealing with imaging data weren't funded. So neuro and digital pathology weren't funded. So it doesn't fully represent everything we want, but we're trying to figure out how we can work together. There are other consortia in the natural sciences that are doing imaging, and so kind of interesting things are taking place. NFDI4BIOIMAGE's goal is, of course, in Germany to make research data management as fair as possible. That has to, though, work in the international context. So this is kind of the perfect meeting to talk to all of you and figure out how we can move forward. And as you can imagine, in the proposal, we did interesting things like taking the fish data and putting it in OME and showing everyone, showing the reviewers, see, we're really doing it, right? Our communities got their act together. The proposals on Zenodo, by all means, take a look. I won't go into much more depth. And by the way, the Zenodo link for this presentation is at the bottom. That's the DOI. So you can click on all the links, and you don't necessarily have to even listen to me. One take home, I think, though, from NFDI4BIOIMAGE, so we're about 1.5 years in, it's a total of 5 years, is that we had to produce a review of our community. And so I did it very much from the OME point of view, but looking at all we've done and what all of you have done, right? And I think we can hold our own with any of the other communities that have been funded. And I think maybe because our data type is so complex, we actually had to do all of that work beforehand, right? And so we're actually having an exchange of experience from all of us now to these other communities and showing them maybe a way to move forward. That's been quite nice, and I guess kudos to all of you. A little bit more concretely, it's roughly a dozen participant institutions and a dozen applicant institutions spread across Germany. For whatever reason, Bavaria is not represented. We did our best. The funding also covered 2 IT centers, so in Freiburg and in Münster. That's not to host the data. So you'll see that's not what we're doing. It's really about testing solutions, training people in those solutions, and investigating what's possible. And then 2 big teams that are represented are the data steward teams. We've been talking about some of that today, and research software engineer teams, really to build the capacity. And those are the 2 that I'll focus on in the rest of the slides. And bringing in from the community their use cases. So we try to reach out, find who's having problems within Germany, and cover those instances. So it's a total of about 20 FTEs, as I said, funded for 5 years, possibly a follow-on 5 years. And then we'll see if there's a sustainability framework within Germany. So that's unclear to date, but it's more capacity than we've had so far. Clearly working the other NFDI consortia, and as I said, working with all of you, with the international partners, but also reaching out to industry via BioImaging and Derby and all of the other kind of industry boards that are out there. So the data steward team, very briefly, I think there are actually a few more. I need to update the slide. They run a national help desk, seeing who needs, has issues with Omero. It's either installing Omero or getting data into Omero, or really anything across the gambit. So are our tools working? So everything that you all have presented, can people actually make it work? Also, as oddly as building calendars out of existing data, doing all the outreach to show people this is what it takes, this is what we're learning. More interestingly, perhaps, is that now that they're trained up and are doing all, supporting all these use cases, can we even go so far as to have the data stewards get data into the IDR? Is that something that a national body can take responsibility for? If so, maybe that's a conversation we could have in the sense that other nations could also step up and help us get into our data into the IDR. And where's Matthew? He showed up not too long ago. Also help Matthew and the team get things into the Bioimage archive. We need to be creative about the models of how we get things moving forward. And then now much more from the research software engineering side, because that's the hat I wear, and I actually brought the hat, is developing a standard for all of this. So the objectives that we have cover the full life cycle of research data management. But fundamentally, I think for so many of the things that have been brought up today, what we really need to talk about is a standard where we can actually write this data down in a consistent and singular way. Can we come up with a common representation of what all we're doing? So that's what I'll focus on. There's me in the hat on a river somewhere, upset my wife to no end. And so let's talk about 2 things. Let's talk about the data and about the metadata. And I'll do my best to keep that roughly in time. As many of you all know, over the past 6 years, we've been working hard to develop a next generation file format. So at the I2K, the Images to Knowledge meeting 2018 in Heidelberg, we looked at one another and as a development community, and we said, we're going to do this. There were no major objections. Let's try to do this. And so since then, we've been working at it, right? I think I need to click to get the adopters moving. So what a next generation file format is a way to take very large files that are getting too difficult to deal with, and many of you have talked about that, and break them up into multiple pieces so that you can access them, for example, from the web more easily, right? And once you do that, once you break the file open, you can also take out all the header information, all the metadata, and put it into easy use representation like YAML or JSON. And so that brings us to OME-ZAR. That's the file format that we're working on. The benefits are you can write those things in parallel. So the story goes, so someone at Genelia, so Stefan Saalfeld, if you know him, was writing data out, and it took on 2 weeks, I think, to write it out to a HDF5 file using one of the next generation file formats. It took 30 minutes. So that's the level of scale that we need to achieve moving forward, and probably even a couple more orders of magnitude. Once you have all those files broken out into a directory, you then want to be able to upload them somewhere and just share them with someone. You don't want people downloading it. They should be able to access it as if it was a website. Put it on S3, looking at Eleni. So I've already sent her links, and we'll get her up to speed. There are obviously downsides, right? It's many, many more files that you have on disk. There's no easy way to lock all those files. The desktop integration's not as good. But those are all things we can work on. But the fact is we've made very, very hard things much, much easier. And so it should be exciting times for all of you. And the adoption, oh, I guess my movie stopped. It should have bounced. the adoption is what's the word? Exciting, I guess, if you can call adoption exciting. That we're seeing larger and larger groups move to this format ZAR, and we want to keep that going. To what degree can we make this actually a standard that we're all using? So what that looks like, okay, now the video plays, is you can build very simple websites here on GitHub, just a static web page that's inspecting all of this large data. So on the left, looking at the metadata, all without downloading it, can calculate the sizes and all the bits and pieces of the data, and then critically, you can send a single URL to various applications and just have it work, right? So here we send it to NeuroGlancer that Bill showed you, WebNosis, which was mentioned once or twice. Those are web applications, so there are links, and you can go off and you can play with those again and just not listen to me. Napari and Fiji are a little bit harder. You have to install those. If you want to install Napari, talk to Juan. Otherwise, I can help you get started with the Fiji. But to make this URL, the single link to your data online that doesn't have to be downloaded, the standard of how we're all accessing things, right? That would be the vision. I think we're getting there, getting pretty close. It's more than just an image, though. It's a quite complex structure that we can represent here. There's a lot. So this represents much of the specification as it stands today. We tried to cover everything that was a part of the community in 2023. Got about 70 people who were actively developing on OME-ZAR together in a large kind of review paper. Check it out if you want to know more. But the question I think for the community is, where do we want to take it? What all do we want to put in it? And what are the pieces that we all need to make our applications work? And interestingly, Juan then showed up and wanted to talk about what he would put into OME-ZAR. And so we're going to let him do that. But think of it very much in terms of what would you like, right? And find me or find the community and let us know. You don't have to clap. Go on.
Yes, actually, this is my first global bioimaging, and I didn't know what it was about. So I thought I would meet like everyone working on OME. And I think there's a few of you here. Rhoda, are you okay. And so, yeah, I'm working on a modification to the spec. Should I move this? Yeah. Josh is tall. Okay. So, yeah, so we can all participate in the spec, which is really cool. So right now, if you go to the specification, if I hadn't moved the screen, it would show you that you have to have the dimensions T, C, Z, Y, X. Everyone knows that. But actually, there's more dimensions. So that's what I'm here to talk about. I would like to be able to store things that are not in the T, C, Z, Y, X scheme. I'm going to show you a few things, hopefully to convince you that you can go to this RFC tree and support it and say that it should get accepted immediately without review. Okay, so as a background, I co-founded and work on Napari. Napari is now led by many, many people. I'm just one of them. But I think there's two big ideas in Napari. One is that it was in Python, so that automatically made it a really good choice for a lot of people who are using Python. But the other one is that it is n-dimensional. It doesn't care what dimensions you give it. So I've given it here T, sorry, no T, there's no time point. So there's C, Z, Y, X image. This is a quite famous image now from the Allen Institute for Cell Science. So whatever dimensions you give, Napari will show you the canvas and then put sliders for any extra dimensions. So here I'm on a 2D canvas. And if I switch to the 3D canvas, it gets rid of the slider and just shows me 3D. I can also do T, Z, Y, X. And then this is using the Napari OME-ZAR plugin that lets me read a multi-scale T, Z, Y, X. So now I have, I can move along the Z-axis, and I can move along the time axis. And if I switch to 3D, I get a 3D, I still have my time axis, and I can see the. Okay. And it's not just that. If I give you a 10-dimensional image, Napari will happily give you 10 sliders. But you might say, one, this is absurd, no one has 10 dimensional. Okay, so let's talk about real analyses that people have done. This is from cryo-electron tomography. This is subtomogram averaging. So you take a subtomogram, you take a tomogram and then you find particles in the tomogram and then you try to align the particles so you can do a structure from the particles in the tomogram. And so then what you end up with is a whole bunch of little volumes. They're 64 by 64 by 64. And you can do a PCA on those. So what Alistair Burt, who was in Cambridge at the time, but is now at Genentech, did is he ran this, and now what you can do is look at Napari and see the variability of your principal components along your principal components. I'm going to do a interpolation. So this is now my z-axis. What we're looking at is an array of chemosensing molecules on the lipid bimembrane in a bacterium. So this is a principal component, and this is now the position along the component, and you can see that sort of has a little bit of a squish along one axis in this principal component. So all of the variability of this axis is in this shape. I can also switch to 3D view. That's the array of the chemosensing molecules. Sorry that I'm a bit clumsy with this. There's another component, which is the 11. And here you can see that the curvature of the membrane is what changes along this axis. So you can use Napari to explore this 5-dimensional data set where you've got 2 dimensions, which are the principal component number and the position along that component, which are either T or C. So that's one data set that I would like to save. Currently, OMEZAR does not support that. So I just have to regenerate it every time. Another example from BioNorthern and Ian, last name I've forgotten, I'm sorry. So they've done this thing called Napari segment everything, which lets you find every object in an image, and that means that you have overlapping labels. So you no longer get a segmentation like you would normally get in in a cell analysis. You have overlapping labels, so you need an extra dimension to store the labels. So you see there's overlapping objects, but this is actually a 3D labels for 2D images, where every object is sort of one position along Z. So this is like the finest segmentation you can see, and if I flip the image, you can see the coarsest segmentation. Of course, you can also just go back to the 2D view and then find all of the objects in different. So again, one more dimension. This dimension is coarseness, I guess. And the final one, I've started to work with material scientists, and they do this thing called electron backscatter diffraction. So do a scanning electron microscope, and then when they fire electrons, you get a diffraction image at each position. And this tells you something about the structure of the crystals in the metal that you're looking at. So now at every position, as I said, you have a diffraction pattern. So these are the diffraction patterns. And on here, you've got X, Y, and then the 2 dimensions of the diffraction pattern, which I guess I can call dx, dy. And when I scroll through here, this is one crystal grain, the boundary between one crystal grain and the next crystal grain. So every time that you get a change, you're moving into a new crystal in the metal. And so you can use this structure of metals. Okay, so in conclusion, go have a look at the OME RFCs, support, be the change you want to see in the world, and make sure that OME works for you, the new OME ZAR works for you. And then one last bit, I'm really excited about everyone I've been meeting here. Please come talk to me if you want help with using Napari. If you want to host a Napari hackathon, we think we're going to be doing one next year. And if you want to support Napari by hosting a workshop, if you need training, then we have core developers who will come and make users. Or supporting Napari in any other way. We are trying to sort of grow the community and our independent funding, so we're open to ideas. All right, back to Josh. Sorry.
And that was just the additional information. Not accepting RFC without review, but we could talk about using the notebook for the review. Okay, we'll discuss later. Okay, so all these kind of ideas are coming constantly, right? I mean, obviously, you all have huge ideas, great things we want to do. and it's happening constantly. So we want more of that, but we have to have a way to move the community forward. So at the OME 2024 community meeting, so we hold one annually, we had this idea of trying to host a challenge to push us forward, right? So Juan told you about RFC3, RFC2, so the previous one was to move OME ZAR to the next major version of ZAR, which is called ZAR v3. It has sharding. It deals with the many different files that you have on disk and makes things generally happier for the IT departments that you all want to make happy, right? So the idea, or the general goal, kind of pulled out of the sky, was to reach a petabyte of data in 4 months that everyone in the community could convert and add to. I didn't want a petabyte of data in my data centers, so everyone had to bring their own storage, right? But it would hopefully, through this process, we would see that we could actually get the spec moving forward. We realized, though, fairly quickly that we need something to deal with all of these images, because otherwise you just end up with something like 15,000 individual ZAR URLs, which isn't too useful. So we built kind of a lightweight viewer built on CSV. So we kind of did the simplest thing we could imagine. So at the top level, we have one CSV that points to every contributor in the community that wanted to participate, and then they could have a CSV, and those CSVs could have other CSVs, and at the bottom are ZARs, right? And it's just a way to see the data. So this is the viewer as it looks today. You're welcome once again to go play with that and ignore me. But it is a way to represent all of this data. The numbers, so 4 months, as I mentioned, really the organization of doing this took us about 9 conference calls. For anyone who doesn't know, OME, when we run conference calls, always run the conference calls twice, once in the morning, once in the evening for all time zones. So it's 18, but most people just came 9 times. It was a lot of development work, right? We have all kinds of versions that we're juggling to make this happen, because it's not the specification, right? We're just testing something. And we made 50% of our goal. So in 4 months, 500 terabytes. But looking back, what someone realized inside of the challenge was that in that span of time, we had built a federated image repository, all using the same format, right? That's actually really, really exciting. Didn't realize we were going to do it, right? It was kind of like, oops, damn, it happened. But that's great. And that's what I was talking about. We're making very hard things easier, and we want that to keep going. People are taking pictures. I'll wait a second. So if we want more demonstration, I can bring this up. It's not my laptop, so I don't know if anything's going to work. Okay, there it is. So you all can go do this. You all can go do this yourself, of course. I'll just click around a little bit. I noticed last night I wanted to build some movies to do this rather than doing it live. The thumbnails are loading a little bit slow from, is this Edgerome one? And the hotel was very slow. But all of this is done on the fly. So you can click through. So the images from Germany are all here, so 2 terabytes. All the ones from the IDR that we have, see it's loading. Anything that's very large in X and Y will be slow to generate. The thumbnails, I won't wait anymore. One interesting point on this list is the WebNots data is not actually converted. They're generating it on the fly. If you really want to drive them nuts, you can download those ZARs because it forces them to do all of that. So as far as I know, all of that 300 terabytes has not to date been converted, but it can be if you want it. A little bit of metadata is available. So we limited ourselves in the challenge very much. So there are various names. So these are basically the names of the CSVs. So the contributor chose a collection. There's obviously the dimensionality that you can click through. And then for the challenge, we said we would just do organisms and imaging modality. And it was actually hard enough to agree on that. Metadata is a big topic. We'll get to that in just a second. And then from here, any data you find that's of interest, we know that the license is CC BY or CC0, so you're welcome to take it. You can run your analyses on it. Have fun, right? That's really, I think, what a lot of this is about. You can click through, open the validator. So the validator is where certainly the OME team always starts. If anyone says they have an OME ZAR somewhere in the world, we will validate it. And you will get an email if it's not valid, right? We had this with OME TIFF, that various stakeholders were generating OME TIFFs that weren't valid. And that's an issue that we want to nip in the bud, but with OME TIFF, we'd have to download it, right? We would have to do the work of pulling down all of those terabytes of data to validate it. and we don't have to do that anymore. So for our point, the validator, getting this green check is really our starting point. And then from here, you can, anything that's kind of a check here, will drive through. And eventually, if you keep clicking through, you can get to an image. This is the multi-scale. And here you can say, open it with a viewer. This is VZAR. VZAR is a standard kind of 2D viewer. Why is that taking that long? There we go. I think that's just, okay, I didn't pick a particularly interesting image. Sorry, that's talking while demoing. There are also 3D viewers, but I'll show you why that's a little bit tricky. Where are the slides? For example, NeurogLancer, we had to build a development version. So this is the kind of very complex URL that you need for the development version of NeurogLancer. But at the end of the day, it's just a static URL that you could use. So play around, see if you can break it. I would love to know how much it scales. There are very much more sophisticated systems that we can build. So at I2K in Milan last week, someone from Janilio, so Conrad, so the same person who Eleni was demoing, so the 3D visualization, had also built a website also over the summer, easy to do, didn't talk to us about it, right? Everyone can just develop it. He has a database behind it. So it's a little bit faster, but it's not as simple as this. We can have kind of a spectrum of solutions that we can all use as a community, right? We can do whatever we want. Okay, let's go back to the slides and finish up. I know you want to get out of here. Last topic, metadata. This is the standard citation for bioformats. Does anyone not know what bioformats is? Thank you, good. Okay, so 2010, we made this public statement of how critical bioformats is. I didn't realize, I went back to read this for the OME 24 meeting, the top 10 recommendations still basically all apply. And especially I want to touch on number 6. It says we need data export from the commercial systems to an open metadata specification, right? Obviously, but, so this is, sorry, the green box will come in just a second. These are a handful of the companies that are generating formats. Bioformats is there to parse all of that into OME XML, into the standard model, right? That's how it works. However, there's all this information that gets lost. There's metadata that we can't interpret. And we need to figure out something to do about it. So I've been trying to draw that. So this is a complicated concept that we've been dealing with for years. These are my new drawings to try to figure that out. In our world, so from the point of view of bioformats, the representation of the proprietary file formats is this complex internal state. Bioformats only sees the blue part, only sees a subset, because that's all we know. That's all that has been standardized, right? And the overall goal would be that for all the green blocks, for everything that's custom, everything that a company wants to say, that we have some way to at least partially interpret the data, that we get a little bit of it. So there's uninterpretable information in both sides. Currently, we're losing tons. We're losing most of it. The green blocks all have little blue box inside of it. It's all disappearing. But if we can at least get the blue parts out, then we're just losing a little bit of the green, right? All right, so does it work? Okay. There's a technical proposal on the table for doing that. We built this into the challenge, experimented with it, but it's very, very early days. So this is something called RO-Crate. It's coming from the University of Manchester. It's fairly widely adopted across the European Open Science Cloud. I think it can get us what we need. We obviously need to talk about it. So the RFC for the metadata work will be coming. Anyone who's interested in dealing with that, by all means, get in touch with me. It is critical, if we are going to have a common format, that we can capture a complete representation of the metadata. If we can't, we'll never get to the point where people get rid of their original data, so you'll always have a copy. And that's what we want to end, right? There will be much, much more talk of this at the Founding Guide meeting. If you're sticking around, lovely. If not, sorry to see you go. I think this is the shortest representation of all these problems that I can come up with, especially for the software developers. Creating representations is easy. I could do it every day. Coming up with a common one is going to be hard. And it takes time. And it takes us working together. So I talked to Claire about this. Maybe we want to make something like this our call to arms from this meeting. That would be my proposal. This is what I care about, right? think about it. Maybe we can come out of this meeting making a common statement about where we want to go as a community. A march towards OMESR 1.0, adoption by companies, adoptions by Amazon. You know, what can we make happen to really set a standard for the bioimaging community? All right, that's it for me. Thanks to the wider NFDI for Bioimage community, to all the participant challenges. Not huge representation across all continents. Where's Yara? We can work on that for the next challenge. There will be future challenges, and we need to find the right networks to let people know that they're happening. For the moment, everything happens on ImageSC, so if you're interested in getting involved, don't hesitate. All right, thanks.